I just started the recording now. Yeah. Thank you for reminding me about this. So these are the factors that affect the load, whether it is long-term load forecasting or medium or short-term load forecasting. We have some economical and environmental factors, time factors, weather-related factors, and also random events. The economical and environmental factors, surface area demographics, rural area, residential area, and how the population moves from one area to another, industrial growth, emergence of new industry, change of farming, penetration or saturation of appliance usage, economical trends, recession or expansion, change of the price of electricity, demand side load management. Based on our discussion last class, can we classify these factors to see which of those factors affect long-term or short-term load forecasting? For example, surface area demographics.
I think this is for long-term forecasting.
Long-term forecasting.
I think, Doctor, it is a short-term.
Why short-term?
Because the residential or the rural is, I mean, stationary, or I mean, يعني الدكتور نفس من الناس راح يضلوا في أماكنهم، يعني راح يستهلكوا نفس اللي هو الكهرباء في نفس الأسبوع أو في نفس المكان اللي يستهلكوا فيه.
طيب يعني هو there is no change يعني مش كده؟
أيوة
no daily change يعني there is no daily change.
بالضبط.
Okay. فدي will affect long term ولا short term؟
long term عشان الزحف عمراني
Yeah, now we are forecasting for 20 years from now.
Yes.
And the population now is 10 million. What about the after 20 years? This would be 15 million. And the people will concentrate more on eastern area. We have some, attractive activities or industry or so the people will move from one area to another. This will done over years. This will affect the long-term load forecasting. What about the second one?
Long term too.
Long term.
medium long.
Industrial growth.
Medium and long.
الأخ اللي بيقول ميديم، مين اللي بيقول ميديم؟
Yes, me, صالح.
صالح, medium, what is the time frame for the medium? What is the forecasting horizon for the medium?
احنا قلنا من تقريبا شهور إلى 5 سنوات 6 سنوات.
لا احنا ما قلناش كده، انت كده بتقولني ما لم أقوله.
يعني هو بتوين اللونج والشورت. إذا الشورت بالأسابيع والأيام.
Okay. Short 1 week maximum. Hours 2 week 1 week.
اوكي بالشهور اجل الميديم.
الميديم
months
4 weeks 2 months يعني or 2 months مثلا let's say.
اوكي.
Now long from 1 year to 30 years from now. So industrial growth, this of course will take place over the several years. So this also will affect the long-term load forecasting. The emergence of new industry Again, long-term load forecasting. Penetration or saturation of appliance usage also.
ايش معناها
Economical
دكتور هذه؟
يعني
ابلاينس ايش معناها؟
الابليانس يعني الابليانس اللي هي الاجهزه، يعني الاجهزه الكهربائيه والكلام ده اللي انت بتستخدمه. الناس بتشتري وبعدين في الاخر بيحصل ساتوريشن. رايت؟ معايا ولا مش معايا؟
معك دكتور.
يعني ده بيحصل طبعا اوفر يعني long period of time. الايكونوميكال ترند، recession and expansion. long term اللي هو النمو الاقتصادي، اذا كان يعني فيه يعني نمو اقتصادي بوزيتيف او في كساد او ركود اقتصادي. فده بيحصل over years not over days or weeks, isn't it? مظبوط ولا مش مظبوط؟
Yes.
Okay. So this is also long-term load forecasting issue. The change of electricity price.
Mid-term.
long term.
It depends.
Mid-term.
بالسعودية هنا ثابت.
Exactly. Yes. This is the okay. This is constant here, but if you look at it globally, if you have some electricity market, so the price will change hourly basis. So in this case,
Why,
okay.
Doctor? Why they change the price?
Why they change the price hourly? You mean?
Yes, it should
Right?
be constant. Yes.
لا هي constant here in Saudi Arabia يعني. But if you have an electricity market, this definitely will change. Why? Look at the يعني لو خدنا مثلا renewable energy, okay, and if you have wind, and you know إنه the مثلا the trend of the wind is would be like this مثلا. You have here very minimum value here. Okay, this is over time. So you have very shortage in wind here. That means to cover the load, you need to have the fossil fuel plants. Yani plants that use crude oil or gas turbine, you have to operate, isn't it? واضح ولا مش واضح؟ So in this case, if you operate this fossil fuel plants, so the cost of generation will be higher in this case. The cost of generation will be higher. So in this case, you have a change of the price of the electricity. Not only the wind, could be solar, could be also, if you still remember, the one of the objective of the forecasting is to develop daily load duration curve or daily load curve and load duration curve. Now قلنا ان الكيرف ده is very important, right? If you have load duration curve as such, this is load duration curve, comes at such. So this is the load duration curve. يعني your load will be very high for like مثلا 4 hours. And it will decrease مثلا for this level for 8 hours. And will be very low. This is for another 12 hours. Okay? So within this period, you have heavy load. So that means you have to operate more expensive and not efficient power plants. So the price of electricity here for this high load period will be higher than this load or that load. Especially, for example, if you have a, yes, please.
The electricity will be higher because they use more watt hour. They use more watt hour than usual. That's why the price would be more.
What do you mean by watt hour? يعني you mean load مثلا, energy consumption of the load?
اي دكتور، اذا استهلكوا كهرباء زياده بيزيد عليهم السعر، بس اذا ما استخدموا زياده نفس الشيء، يعني ما تغير السعر، يعني ب 3000 كيلو وات اور السعر حق اليوم نفس حق بكره بيصير.
ماشي، ما اوكي، اتس اوكي. يعني اوكي، let us say take it as such. You have here 100 megawatt and this one is 200 megawatt. Okay, so for this level of load, if you have some hydraulic and if you have some renewable energy, if you have some PV, if you have and also you can operate some of the efficient and more economic power plants. So the price of the electricity cost or the generation cost or fuel cost will be low from the power system operator point of view. اوكي، انا بتكلمش على اللود ان انت بتدفع 17 هلله for كيلو وات اور وذيس از فلات. انا ما بتكلمش عندي، انا بتكلم على الجنريشن كوست. انا بشغل الباور بلانت here for this type of load. انا I have some efficient power plants, I have some economic power plants and I operate them at this level. فالجنريشن كوست بتاعتي مثلا ممكن تكون 10 هلله وانا ببيعها لك ب 17 هلله. اوكي، فاتس اوكي. Fine. Now if your load increases, especially فترة الظهر، فترة ال very hot weather and so on, if your load becomes 200 megawatt, the power system operator, what should he do? He should commit more power plants to cover the load, and these power plants will be definitely less efficient than those carry the base load. Let us say this is the base load. هنبدأ أشغل some extra power plants, and these power plants will is more expensive, needs fossil fuel, and the generation cost now becomes let us say 20 هلله now. Okay, so should I pay by 17 هلله again? Well, I have to increase the price.
Increase
the
Increase the price, especially for the sorry, especially for the electricity market. Yes. If you raise your hand and
Sorry.
Okay, go ahead. Go ahead. Okay. طيب. In this case, if you have electricity market, you have to make a profit at the end. So you cannot generate by 20 halal and pay by 17 halal. So I will increase the price within this period. Okay. So in this case, you have as a consumer, you can go and switch off your appliances within this period in order to reduce your bill, right? So this is the change of the electricity price here for the deregulated market. So this will affect the short-term load forecasting. Is it clear? So
yes, it's clear.
okay, with demand side management also for short-term load forecasting, and this is short-term load forecasting. And some of the environmental and economical factors affect the different types of the forecasting type. Time factors. Does the time affect the loading, the forecasting, load forecasting, or not? Time.
Yes, of course.
Yes, it affects, of course.
How? Can you raise your hand and tell me how the time will affect Saleh Abdullah?
مثلا وقت الذروة، الظهريات، الحر، when the weather
Okay, so
عند
okay, this
at الشتاء والاشياء هذه.
winter, summer, and so on. Yes. طيب, okay, Ahmed Ahmed, do you have a different answer or
Yes,
extra?
I have additional. Yes.
Go
additional.
ahead.
When the people is awake and working.
The day work, working days weekends, right?
Yes.
Morning, midday, and afternoon, and evening, and so on. Yes, all these will affect if you have some festivals, if you have some events, some games or football games or football matches, and or World Cup or whatever, such events also will affect the load forecasting. Seasonal variation of load, summer, winter, and etc. The load changes due to the change in the number of the daylight hours. حتى طبعا هنا في السعودية مش مطبقة، إنما in other countries you may find في التوقيت الصيفي والتوقيت الشتوي برضه ديوتو، يعني بيغيروا في الساعة، يقدموها ساعة ويأخروها ساعة على حسب في الشتاء أو في الصيف، على أساس إنهم يكون most of the day time أو working hours are within the day time يعني. فthis will also affect the lighting and so on، وبالتالي ممكن they can reduce أو بيعملوها mainly for reducing the electricity consumption. Gradual change of average temperature and so on, also this will affect. And as you can see here in this figure, you have total kingdom electricity use. This is, in blue, the average temperature. In red, as you can see, the load matches exactly you can see when the temperature increases, the load also increases, and when the temperature goes down, the load also goes down. And a good matching between the temperature and the load. Start of school year, vacation, also this will affect the consumption of the load. The weekly cycling variation.
دكتور.
Weekly yes, please. Abdul Karim.
Yeah. What's the most device in our home that consume power? Is it the AC?
Again, and I didn't hear your question well.
What's the most device in our home that consume power? Is it the AC?
Yes, you are right. AC.
Okay.
The AC in Saudi Arabia, the air conditioning load in Saudi Arabia represent 65% of the load. Look at this. 65%. يعني تلتين اللود consumption of the electricity goes to the AC. Are you appreciating this number?
Yes.
Very huge.
Yes.
Very huge.
But doctor, we have no control of it, right? I mean, because of our weather, we have to consume power.
Yeah, of course, طبعا يعني of course, but definitely I will answer this question, but let me, if Abdullah Abdul Karim,
Yes, Doctor.
lower your hand, please. If you don't have a question, lower your hand, okay?
Hello, Doctor.
Do you have a question, Abdullah?
Yes, I do.
Okay, go
Yes. Can you go back, please, to the previous slide?
ahead.
The slide before this one.
Yes.
Yes. Is this graph? Can you tell us if this graph is real, and if it is, at what year was that?
Well, I'm not sure which year, but why you are saying this? Did you see the electricity consumption in gigawatt hour?
I think I've read somewhere that it's in Saudi, that it is in Saudi up to 60 gigawatt hour. So maybe this one was 15 years ago or 10 years ago. I'm just asking.
Let us differentiate between the power and the energy. What you are given here is gigawatt hour. That means it is energy. So this energy is power times times time, times in hours, right? So that means when you have, if you have, for example, let us say this is the maybe this is the mid of January. They take, for example, January 15, February 15, March 15, April 15, and you have this, okay? You have this consumption as an average. So that means that this value is multiplied by, the power multiplied by the number of hours per month. That means you have like 30 multiplied by 24.
Isn't this fixed for all months, Doctor?
Of course, you have 31 days, you have 28 days here.
So this is to differentiate the amount of hours in 1 month. Hello? اسمعوني شباب؟
اتوقع قطعت.
ايه دكتور قطع الصوت عندك.
I don't know what happening, but maybe the internet connection or something. I don't know from my side or from maybe
it's from your
my
side, but they were hearing me.
Okay. So of course you multiply the consumption or the power here, multiplied by the time. This is energy, not power. You are right. The load now is about 60 gigawatt. This is the load in Saudi Arabia right now, or 69, I think, 69, 70, like 70 gigawatt. 70 gigawatt.
Okay. So is there a place that we can check for that, like national authority that reports?
There are annual reports issued by Saudi Electricity Company, or some reports issued by ICRA also. This is the electricity regulation, ICRA. Electricity and the cogeneration regulatory authority. This is also one of the Saudi authorization that also issue some reports for the consumption, and also a Saudi electricity company or national grid, you can say national grid company. هم طبعا as you can see also, or the Saudi, the kingdom also is going to liberalize the electricity. So at the beginning, they have only one company. Now they have a national grid, which concerned with the transmission lines and so on. They have generation company and they have distribution company. So this is one step towards liberalize the electricity. You may have some also in Saudi Arabia, you have some independent producers like royal commissioning, and you have also what we call in Jubail, they have a company which is independent of the electricity. What we call it?
Marafaq company.
Marafaq, yes, you are right. You are absolutely right. Yes, Marafaq, and also Aramco also generates some of the electricity, and export it to Saudi electricity company in some of the cogeneration plants and so on. You may have some independent producers, and if you liberalize the electricity market, then you have some investment, and you can invest in one plant, and then you can buy your electricity to the company. Okay, so let us continue. Weekly cyclic also. This is like another pattern for the go for the AC load 65%. You mentioned this is independent. Yes, it is independent, but of course you need to improve this. Maybe by you can have new technology. You may have new technology. Then what is the AC? What is the air conditioning components? It is a motor, induction motor, right? This induction motor, we can improve its efficiency. We can have what we call the adjustable frequency drive. You can have adjustable frequency drive, not constant speed motor, but you can play with the speed of the motor. You can have also new technology for the induction motor. You can replace it by what we call the line start permanent magnet synchronous motor, which is more efficient than the induction motor. This will reduce the consumption of the AC. So if you have new technology, this will reduce the load. And in addition, if you have also demand side management, if you have the new infrastructure of the communication channels and smart meters, and so you can play with the AC load. And for example, you can make it dependent in the occupancy of the building. And if there is no one in the room, so intelligently this will be known, and the AC will switch it off. And if you have more people, you have more consumption. If you have low people, you can reduce the consumption. يعني if you go لو لسه فاكرين البيلدينج 59 مثلا، لو لسه فاكرين يعني طبعا يعني long time we didn't فطبعا زي ما انتم شايفين البيلدينج 59. ها؟ What do you mean? Yeah, exactly. يعني during night مثلا ال AC is working with the full capacity. You can have some doors in the parking down. It's open all the time, and you have some kind of measures can be taken in order to reduce your load. And also demand side management. And you can, for example, instead of setting the temperature or thermostat to 22 degrees centigrade, you can with the peak loads, you can reduce it to 21 degrees centigrade. So in this case, you can reduce the consumption of the energy a lot without sacrificing your convenience. 1 degree is not a big issue, but it will of course reduce the duty cycle of the AC or the period where the AC will operate. So this will also reduce the electricity consumption. Yes, the AC consumes like 2/3 of the electricity, but with some measures you can reduce this figure. Okay, now for the electricity demand, any other question, Abbas, Fuhed?
Yes.
Abbas?
Yes, I have a question.
Yeah, please go ahead.
Which one is most costly? Is it the hot temperature or the cold temperature? I mean, when we switch on the AC with the, for example, 30 Celsius, will it cost more than when we switch it on for the 15 Celsius?
And your question is cooling or heating? Isn't
yes,
it?
exactly.
مثلا during winter we need heating load in some places, of course. During summer we need cooling load in hot areas. This, of course, heating load is very also, is very very heavy. Also, it consumes a lot of power. The heating, but heating this will represent a load in let us say in European countries in northern part, but they use some other technology for heating, not from electricity, and from electricity will be very, very expensive. As you can see, if you have a kettle or iron in your room, this kettle is 2,000 watt, maybe 2,000 watt, which is 2 kilowatt. Iron also is 2 kilowatt. Very very heavy loads. So heating is more expensive, but in that areas they use some other technologies like heat pump from the earth. They can go down the earth, and then they can in the earth down you can have high temperature, and then they can circulate the fluid or gas, and they can do this. Also, they do heating through the gas also in other countries, and you can probably see this. They have gas heaters from there. فأنا I mean إنه yes, heating also is very expensive, but in Saudi Arabia, as you can see, so we have some places where you can need some heating in winter, but it is not as much as the AC consumption for cooling purposes. Okay.
Doctor?
Muhammad Hassan.
Yes, Doctor. Is the starting of the AC will draw very high current and will consume more power? And what's the hour compared to what's hour in the saturation region, for example?
You mean the starting of the AC?
Yes. Yes.
The starting of the AC, of course, consumes, you know, you have, of course, covered the induction motor in 360, right?
Yes.
And you know the current with time, the starting current will be 6 times the full load. The starting current in induction motor. And then this current will take like 1 second, a few milliseconds or so, and it will, at the end, you know, go to the steady state value or the full load current, full load. So the starting is you know, the problematic instant. The motor draws a huge current, 6 times the full load current, and this will make voltage drop due to this high current. And also, if you have some lighting load connected to the same line as AC, you see the lighting will flicker for some time, okay, due to this high load. In order to reduce this effect, we go to the adjustable frequency drive. The adjustable frequency drive can control the starting current of the motor and make it within 2 times the full load current. And you can start the full load current by you can start with the 2 full load current, then the current reduce up to 1 full load current or full load current 100%. So this technology reduces the starting current of the AC. But if you have a plain induction motor without adjustable frequency drive, then in this case you can. What is the adjustable frequency drive, ya shabab? Any clue?
Yes, Doctor. It will change. We can control the frequency of the motor, so we can control the speed of the motor.
Exactly. Yes, you can have as we mentioned earlier, back-to-back conversion. You have AC to DC, and this is 60 hertz. You convert it here from DC to AC with variable frequency. You can kill this frequency by rectifying the AC 3-phase here, and you can have a DC link here, very small DC link, and this is DC to AC. You invert DC again to AC 3-phase, but not within the 60 frequency. You can have it 30 hertz. You can have 35 hertz. You can control it gradually, so you can control the speed of the motor gradually. So this will reduce, of course, the full load current. Saleh Abdullah, do you have a question?
Yes, Doctor. My question is that does the age of the device affect the amount of power that were consumed?
Does what?
Does the age of the device or the model?
Of course, yes. Of course, definitely. And if it is aging, then you can expect the efficiency will be lower.
Okay.
Right?
Yes.
So we have some degradation and insulation. We have, you know, the efficiency will go will be less, and this will consume more power in order to get the same load, in order to cover the same load. Abbas Saeed, do you have a question?
Yes, Doctor. In the process of converting AC to DC and then DC to AC, how much approximately the percentage of lost power?
Well, the conversion process is very efficient. يعني you can have here like 98% of the conversion, and you can have here also 98% of the conversion. So you multiply this 98 by 98, so it comes to like 0.96 efficient, 96% efficiency. But the of course you have to do some, cost benefit analysis. You have some losses here in this conversion process, but what are the benefits that you can get if you have variable speed drive? And you can reduce the consumption of the load by like 30% or 40%. You can reduce the consumption of the power compared to 4% of the losses. Of course, your benefit is more pronounced than the losses exerted by the new installation or new devices here. Definitely the adjustable frequency drive is more efficient than without this or line start. You just connect the induction motor to the line directly. Okay, so let us continue. You have here like typical weekly load pattern. This is for the first 24 hours, first day, second day, third day, fourth, fifth, sixth, and seventh day. And you can see here the cyclic behavior. We can expect these days represent the, what do you think? Working days or weekend? Where the consumption here, your consumption here is a little bit.
هذا ويكند شكله دكتور، الناس برا.
ولو جوه يعني هيختلف؟
إذا حيدجوا بيولعوا المكيفات وحيروح فوق.
بس لاحظ انه ممكن يكون في الكوميرشال، الاوفيسز، الاندستريال بلانتس برضه في some of them are switched off or not working during the weekdays and so on. فيعني this is also we can say you have to look at different factors, but this is most likely this is the weekend and these are the working days. The blue one for winter week and the summer one is the red curve that you can see here. Do you think this load is within the Saudi Arabia?
No. No, doctor.
No.
Why?
In Saudi Arabia would be much higher than this.
Winter is higher.
In the summer, in Saudi Arabia, in the summer it will be higher.
Yeah, summer will be higher than winter, definitely in Saudi Arabia. Most of the country, of course. The summer consumption is higher than the winter consumption. Okay, let us continue. Time factors also daily variation of load components, night, morning, etc. You have here agriculture and other. You can have some of the flat load. For industrial also you have some of the increase in during the day time. Commercial also you have increase during the daytime starting from 7 a.m. up to 11 p.m. You have high consumption in terms of commercial load. Residential also very low at 3 a.m. up to 6 a.m. the people start waking up and going to the work and so on, operating. At night you have high load, peak load here for residential and start decreasing up to this. The total load is as such. So the load here is low, load here is peak value during 2 p.m. up to 6 p.m. and so on. So time will affect the load. Holidays and the major events also affect the load. Significant reduction of load with holidays and the major with holidays, and for major events maybe the consumption will increase. Days proceeding or following the holidays also have a reduced load. Some people take long weekend, day before or day after. So type, okay, let us move to the fourth category of factors that affect the demand. The weather affects load curves of the weather sensitive loads. The weather sensitive loads are air conditioning, house heating, and irrigation. And the most important parameters here is humidity. You have to look at the humidity. If you have a high humidity, then you expect the load to be more thunderstorms. If you have very cold weather, then in this case you have more heating required in other countries. And wind speed also, this will reduce the load. If you have rain, fog, snow, cloud coverage or sunshine, so all these will affect the load forecasting. Of course, you have to have weather forecasting in order to improve your load forecasting. Random factors like start up or start or stop large loads, steel mill, factory, furnace. This load is very heavy load. You can just imagine that we have visited Hadid in Jubail, and Hadid has 6 furnaces. Each one is like 150 megawatt. Are you appreciating this number?
Very high, very high.
150 megawatt each furnace, and have 6. So that means in 1 giga, almost 1 giga. This load is almost 1 giga. It needs like half of the Qoraya power plant. الأولد الأولد اللي هي 2 giga or 2.4 giga. Just one load, one factory needs like 1 gigawatt. Of course, such we cannot, we cannot operate it directly. You have to coordinate with the Saudi electricity company. This company, Hadid, should coordinate with the Saudi electricity company. And they said, okay, at 10 a.m. I will switch on one furnace. And at 2 p.m. I switch another one. I will switch off one. Switching on or switching off. You have to have a schedule here. Their schedule should be communicated with Saudi electricity company in order to predict the load. It is very difficult to switch on such load. This will make the system unstable. If you switch on, the frequency will go definitely below the limits, and the protection relays will operate and switch off some generators, and then you will have a big trouble. And also, if you switch off this load, if you switch off this load, this is also another problem. The frequency will go higher than 60 hertz. The generation is much higher than the load in this case. And this also will be problematic if the protection relays operate and switch off some generation. It will create a stability problem for the system. So you have to coordinate with the company in order to make sure their generation and reserve is adequate to cover the load. Wide speed strikes also, this could affect the load. Sporting events, popular television shows, shutdown of industrial facilities, as we just described here. All these random effectors will affect the load forecasting. طيب, okay. So the different load forecasting types are different, use different sets of load listed before. As we mentioned, 2-3 years of data is required for the validation and the development of new forecasting program. You have to have good historical data, good amount of historical data in order to validate your forecasting. The practical use of forecasting program requires moving time window of data. You may not use the 3 years data, but you can have a moving time. Let us say the 1 month and then go to the last month and so on. 30 days window you can take from time to time. The forecasting is continuous process. You forecast and then you have the actual load, and then you can modify your forecasting and forecast again and so on. So it is not only if we need to forecast for 1 week, this will be continuous process. We will forecast for this day, and tomorrow we will forecast for another week. So that means when we update the forecast of the 6 days and so on. So forecasting is a continuous process. And utility forecasts the load of its surface area. The eastern area forecasts the load for the eastern region, central area, western area, southern and northern area. The forecaster prepares a new forecast for every day for short-term load forecasting, updates the existing forecast daily, as we just described here. Okay, now forecasting methods. How to forecast? Okay, so we have some qualitative methods. This use some management, judgment, expertise, and opinion to predict future demand. And this is mainly used in long-term load forecasting. Quantitative methods that we will cover in this course, time series method, which is a statistical technique or techniques, is more than one technique that can be implemented, use historical demand data to predict future demand, and also regression methods, which attempt to develop a mathematical relationship between demand and the factors that cause its behavior. We need to establish some mathematical equations between the historical data and the forecast, and we can forecast based on this mathematical methods. So the first step for forecasting is choosing the forecasting technique. Are you going to qualitative, quantitative? Is it time series or regression? This, of course, depends on the data. It is not a trivial task. You can say time series or regression, but you have to investigate this in order to select the proper technique. It depends on nature of load variation. Before choosing a practical method, basic understanding of how load behaves is essential. You may need to display your load. For example, let us say, where is the cursor? Here. If you plot your data,
دكتور ترى ما نسمعك، قطع صوتك.
دكتور, your voice is gone.
Okay, so back to the lecture. Back to the lecture. Yes. So if you have this type of load, as you can see here, so probably you can say, no, this load is oscillating around an average value, right? So maybe average value is enough. If you have, alternatively, if you have your load is going as such, so maybe you can say, no, it is not an average, but you can have a trend here. So we can approximate this load by linear regression. You can approximate this data to a straight line equation, and then we can get the forecasting based on this equation. For this, of course, you have to understand your load behavior. Okay, is it clear? Okay. If on the basis of historical data and the good judgment, simple extrapolation appears to be sufficient, as we mentioned here, and choosing the best technique requires good judgment and knowledge of advantage and disadvantage of various available methods. Once a method is chosen, its effectiveness must always be re-evaluated. You have to re-evaluate, and as we mentioned, this is a continuous process. So this flow chart gives you the forecasting problem steps. First, you identify the purpose of the forecast, whether it is long term, medium term, short term, which one, and based on this, you can collect your historical data. Your historical data for 1 week, 1 month, years, decades, if you go for long-term load forecasting and so on. And then you can plot, if possible, you can plot your data and identify patterns. As we mentioned, whether it is oscillating around a certain value, or you have a trend, or you have a cyclic or seasonal behavior. And in this case, after having this, you can select your model. You can select your technique for forecasting, a time series or regression method or others. And then you can develop your forecast based on the historical data. And you can evaluate your forecast. You can check the accuracy. You can compare with the forecast with the actual demand based on the historical data. And is it if it is okay, if it is acceptable, accuracy is acceptable, less than 1% or 0.5%, you can set a threshold here. If it is less satisfied, okay, yes, you can go forward. Otherwise, you can select a new forecast model, new technique, new method, or you can also increase data. You can remove some of you can filter out your data. You can remove some outliers. You can expand your data for more years or more days, and then you go you circulate here. You can circulate here until you satisfy with the method that you use. If the accuracy is okay, then you can go for forecasting of the horizon, 1 week, 1 day, 24 hours or so. And you can adjust the forecasting if you have some qualitative approach or information. You can add it here, and you can monitor your result. And then you can estimate the accuracy of the forecast. And if you go here and back forth to check the convenience, acceptable or not acceptable, in this case, you go here and change the method, or you continue adjusting and so on. So this is the forecasting problem. Okay, so let us take the time series method. If you have such data pattern, as you can see, or as we just discussed now, you can say, this data is oscillating around an average value, right? So maybe we can take the average of this data, and we can assume the forecast here equal to the average. This is one way. But here you can see the data is increasing. So we have some trend. So you can approximate this by a straight line equation, and you can go to the regression methods. Okay. Here seasonal pattern. You can say no. This is, for example, winter demand. This is the spring demand. This is the summer demand, and this is the fourth quarter of the year. This is the autumn demand. Okay, and back to winter, spring, summer, autumn, and so on. So you have seasonal demands, seasonal patterns. So you can take this also into consideration. Here you have some decreasing and then increasing, and maybe this will decrease and increase. So you have some cycle here you have to take into consideration. So displaying your data will be very helpful to fetch the features embedded in your, and of course this is very good application for the machine learning techniques in order to fetch the or to extract the features embedded in your data. Okay, so we have only the historical data, and these methods of time series method, we have several methods here: naive forecasting, simple mean, moving average, weighted moving average, exponential smoothing, and adjusted exponential smoothing. Let us move here to the naive forecast. Naive forecast is, let us skip this, will be repeated later. Naive forecast is simply if t plus 1 equal to demand at the period t. So forecast for the next period equal to the demand at the present period. So this is called naive approach, trivial approach. For example, if you January is measured, the actual demand is 120. So what do you expect the forecast for the February based on this naive approach? The forecast of the February, which is the second period, equal to the demand of the first period. If t plus 1, t is 1, 2, 3, 4, and you can have here t equal to 1, period 2, 3, and so on. So F2 equal to D1, and the forecast at the period 2 equal to the demand of the period 1. So this is very trivial approach. So based on this, how much is the forecast for this period, the February?
120.
120 equal to this. For March. For March.
90.
90. And here for April
100.
100 and so on. طبعا of course probably you already know this. No, this value is not known at the beginning. We are in January and we need to forecast the load for February. So we forecast the load as 120. When we are in February, the actual load becomes 90. That means our forecast is a little bit, we have 30 megawatt as a difference here. For March, what is the forecast? 90. What is the actual value? This will be known after forecasting. It is 100 and so on. So this is a very trivial forecast. For October, for example, the forecast in October equal to 110. And forecast in November, if you want to forecast in November, the forecast of November equal to
90.
Equal to 90. Okay, so this is the simple forecast or trivial forecast. The other method, which is this is the forecast as we mentioned here. Okay, simple moving average. A simple moving average is simply you get the average of the earlier periods. Yani for example, if t plus 1 here, the forecast at the period t plus 1 equal to the moving average of the last n periods. Yani last 3 periods, last 2 periods, last 5 periods, last 10 periods. Yani you can of course change this n. This is a control parameter. Yani if you go back to the flow chart and we say no, let us adjust the forecasting method or the technique, you can go probably if you choose 2 n equal to 2 and you found the error is high, then you can go to 3 and you may find better result. You can go for 4, 5, 6 and so on. So you can change this. This is the control parameter here. So moving average for the last n periods. So for example, if n equal to 4, so that means you consider the last 4 periods in order to get the forecast for the 5th period. Let us go to this one here. Maybe when you want to get the forecast here, if you choose n equal to 3, مثلا, you go to the last 3 periods of this. You need to forecast here. So you go to this one and this one and this one. These are the last 3 periods, and you get the average of those. The average of those will be like 235, and you divide by 3, then you get the average for this forecast. So this is the moving average, as we mentioned here. If n equal to 4, so forecasting equal to the last 4 periods, 1, 2, 3, 4 periods, and you get the average. You divide over 4 for this. If you need, for example, to get the forecast for the 5th period, so you take the forecast for the last 4 periods, D4, D3, D2, and D1. Is it clear? Abbas, Fuhed?
Yes, yes, doctor. Based on what do we choose n?
This is, as I mentioned, this is a design parameter. This is a design parameter. That means you need to adjust it. You need to check your forecast, and then you adjust it. Maybe you start with 2, and then you go to 3, and if your forecasting error is still high, then you go to another value and check it, and so on. Is it clear?
Yes.
Okay. Ali Muhammad, time is over. أنا بس just
Doctor,
do you have a question?
Isn't more periods will increase the accuracy of forecasting?
We will see here the trade-off between the the n and the accuracy of the forecast. There is, of course, definitely a trade-off. You can say a trade-off between the number of the periods considered and the accuracy of the. We will see the effect of this. Okay. And I would like to. Okay.
Doctor?
Yes.
Don't forget to save the recording in the general chats in the Microsoft team.
It is there. Did you find the it should be there.
The one of last week, it's not there. I couldn't find it.
How it comes? How it comes? It should be there. You can download it. And personally, I download it from there.
موجودة.
It is there. I think you have to go to the general and see the recording. Maybe it is hidden somewhere. You have to check the replies and so on in order to do this. Okay.
Okay, Doctor.
I just want to take the attendance. I don't know, the mouse is freezing. I don't know. Let me stop sharing. Be frozen. I'm not sure. No. Okay, I will take the attendance from the Insight. I couldn't download it from here. I think everything is frozen now in my PC. So let us continue next class, Shabab. And if you have any question, continue and raise your hand. If you don't have question and you want to leave, you can leave now. Okay.